All right, we got 13.8 on the books today. Next week we're starting 14. I'm making the videos either today or tomorrow morning. For 14.1, 14.2. I will have a practice exam for you shortly. We will do a review for this chapter next week, and the test will be not this Monday, but the following Monday. That way you guys have a day of review before the test and a weekend at Starbucks before the test. I didn't want to jump right into the test on Monday because then we wouldn't have had a day for review. And so that's where we're at. 13.9 is not on the test. Lagrange multipliers is some work. So I didn't put them on there.
Does the test have chapter 14?
We haven't covered chapter 14 yet. So how the fuck could it have chapter 14 on it?
Eric was
Don't make me come in that class and just slap the shit out of you, Brandon.
Okay, it wasn't me that wanted the question answered. It was Eric.
Yeah, no,
Oh.
The bus.
That sure didn't sound like Eric.
Yeah, because
Eric, why? I'm not going to test you on top. This is we're doing the exams are per chapter, but we're starting chapter 14 because I'm not going to do the review and then do nothing for a week while you guys practice. So we'll continue lecturing, but the test will only be on chapter 13.
Gotcha. Yeah. Yeah. When you're doing tuning, you have this and this.
Right.
Yeah.
This is what 2 times 2x is what.
Yeah, but you're gonna have when you do the tuning, you're gonna have negative 2x plus 2 minus 2, sorry. Because you're doing tuning with the you might have had these together without doing the this one.
Oh, okay. So, yeah. So I didn't apply the negative here.
Well, you didn't apply the negative as well, but you're doing the tuning every day. So you on the tune, so that includes the x for the end of 2x. This one's 5, but this one should be negative 2x minus 2 to this.
Negative 2x minus.
Yeah, because you're finding the derivative of this once you take it out and do the chain rule.
Okay. So then this should be 2x minus 2 multiplied by all
Yeah.
this. Got you. Thank you. Yeah, because I was treating them like they were multiplied, but they're not.
Yeah.
They're okay. Thank you. Bless you.
Thank you.
Negative. I still got the same function. So rather than rewriting it, I'm going to do that. And then I'll take the derivative of the inside. No need for a smiley face variable to avoid writing all that big function again when I've already got the function. And we know this does not equal 0 anywhere. So when I set these equal to 0, the only parts that matter are
What you pulled
this
out.
and this. Right?
Yes.
Because this is e to anything is never, e doesn't cross the x-axis. It's never 0, so I can divide both sides by it. In fact, I'll divide by the negative too. And so we get x has to equal -1 while y has to equal 0. Now, so that's just telling me it's a critical point, right?
Mhm.
That's all we got there. We're not even done. It looks done because we found a result, but we're not done. This is only going to get you 2 points out of 10 on the test. Well, maybe a little bit. I don't know. Maybe 3 out of 10. We still got to determine what it is. So what? And we have to go with the full form for doing f of xx. So this ends up being a chain rule or a product rule. Well, both. Let's see. So the first one we got, I'll just do this one first. We've got -2f xy. And then we got to do the derivative of that part again, which is just the -2x plus 2 again. So we would have f of xy times 2x plus 2 squared. And that kind of looks like how f of y works. We're going to have -2 f of xy plus f of xy times 4y squared. So we're doing -1 and 0. That's just, I know I could have had the e's in there, but why write out all the e's when I can just find what f of -1, 0 is real quick. We have e to the -1 minus 2 is -1. E to the first?
Yes.
So fx x, I've got -2e plus e -1. Oh shit, that zeroes out, right? -2 or -2 plus 2 is 0. So that term will go to 0 when we do the next part. fxx is just -2e. Maybe I'll write it just to show what I'm doing.
Let's write 0.
And that's also 0. So -2e on both. So what do the mixed partials look like?
Bless you. Bless you. Bless you.
More time. You're right.
Thank you.
You're welcome.
Your immune system is working
That is true.
hard.
I'm working a little too hard.
That looks like 0. When we plug in the y, that's gonna equal 0. So our D is negative 2e times negative 2e is 4e squared, which is greater than 0. And both of our second order partial derivatives are less than 0, which means it's concave down, which would make this a max. We have a local max at negative 1, 0. And since there's no boundary, there's no way that's going back up. That would be an absolute max.
Yes. It comes from the 4y squared. Would you mind scrolling up? Y. When he does the second derivative of the second partial of y, the chain rule does the same thing as it did in the first one. So it'll give 2y as well. So, and you get 2y multiplied by 2y. It's just the chain rule twice. Does that make sense?
Yeah, Brandon.
Yeah.
Did you say if I'm gonna butcher the name, was it Lagrange? Or-
Lagrange.
Yeah, is it gonna be on the test or no?
I don't think you guys haven't even learned Lagrange. Is Lagrange 14?
Lagrange is 13.9. It is not going to be on the exam. We're going to do it at the end of the semester.
God, that's
But you guys are gonna do that, and this is not Lagrange is very useful.
just a lot of work.
It makes it easier.
You guys ready for another?
Yes.
Yeah. That's
4x squared uy.
e to the y, yeah.
Yeah, it's 4x squared e to the y minus 2x to the 4th minus e to the 4y.
Gotcha. what I did.
It should be x squared is equal to e to the 3y.
He was doing the left side, not the right.
Oh,
He's doing the left
never
side.
mind.
He was doing zero product rule.
Sorry, my mistake. No, I see it.
Is that possible?
So
Can that ever happen?
I just
Like, will both sides ever equal zero?
it's not that this condition just has to hold. Because this was the case, what we started with. So let's think about it. X equaling 0 is not going to hold. So
Wow.
that can't hold. Because if I do 0 over here, 0 equals e to the 3y doesn't happen. So x equals 0 is out.
Yep.
So do we ever have e to the y equals e to the 3y? 1 equals e to the 2y.
Why do?
So y equals 0. Well, what happens with x?
Plus minus 1.
X would have, x would have to be plus or minus 1.
Yeah. To make those conditions hold. Good catch. So we should be checking 1, 0 and negative 1, 0. I brain farted. I'm like, how am I gonna find X? Just plug in Y, dumbass. All right, so. Well. Let me write these over here. And I don't need all this room cluttered up right here. So what's fxx? 8e to the y minus 24x squared. And fyy is 4x squared e to the y minus 16 e to the 4y. Which is convenient because it doesn't matter which thing I plug in, plus or minus 1 for x is going to be the same either way. At our point, this turns into 8 minus 24 is negative 16. And this turns into, let's see, 4 minus 16 is negative 12. And so both are negative. Look at XY real quick. That with respect to y is just 8x e to the y. Which is the same thing as fyx, okay? And that's just 8 at our point. So D is negative 16 times negative 12 minus 8. That's going to be greater than 0.
Isn't
And
f of x y squared?
what?
F of x y, when you do it, isn't it squared?
Minus a square.
I'm taking the derivative of this.
Yeah,
That goes to 0. This is just stays the same.
yeah, but the f of x y, the when you're doing
He's saying that in the double derivative test, if because you're supposed to square it if you did that. So that's what he's asking.
Oh, yeah. Sorry. That what you're going with? You're right.
yeah,
Yeah,
Yeah.
squared. Yeah, there you go.
All right. So that isn't necessarily as intuitive. Let's see. It should be. This is 16 is greater than 8 and 12 is greater than 8.
It'll
So
still be positive.
it should still be positive without doing the calculation. So, and then fxx, fyy were both downward. It's concave down. These are
relative
both 1, 0 and negative 1, 0 are
relative.
local maxes with no local min between them.
With what?
Wait. Can you explain how you came to that assumption?
Did we find a local min anywhere?
No,
Then one doesn't exist.
but would we
Would
have
have found it.
But would we have to specify what you specified there on the test?
No, I was just adding this in. This is to give you some insight.
Oh, okay.
In when we do y equals a function of f of x at f of x, if we had 2 maxes, we had to have a local min for one variable.
Right.
When we shift to 2 variables, that condition no longer holds. We can have 2 maxes with no min between them. And just so you can see it, it is actually in the book. They show a picture of it. So there's a peak here. Let's annotate. There's a peak right there. There's a peak there. This looks like a valley between them, but since it's going downhill that way, it doesn't actually count as a local min right there.
Yeah,
So in this system, there is just two maxes. Kind of neat, right? But you did not need to specify no local min between them. That was more of a learning thing.
can you move it
Ready
up?
for more?
Can you move it up real quick? I want to take a picture of that real quick. Pretty much just like double derivative down. That's pretty much all that I need.
You also need the partial. Or the partial. For the
No,
derivative test.
I already got all that. All right, thank you.
Yep.
So, second partial.
All right, now we got a bounded region. So
You hit this with a triangle and
this is similar to one, well, it's like one of your homework problems. It's the one in the book that isn't your homework problem that has a triangle. So the critical, did you guys get the only critical point without checking boundaries yet? Only
Yes.
critical point is 0.2.
Yes.
All right, so I recommend when you're checking boundaries, be very systematic with what you're doing. Like label them and follow what you're doing. So A is the bottom line. Along that line, y equals 0. And so f of x, y can now just become a function of x. And it's negative 2x. So g prime is negative 2, which does not equal 0 anywhere. So there will be nothing along the boundary there, but inside, but they check the endpoints. So no along the line, none along the line. But maybe endpoints. We'll do that the same for each of those. Along B, what's the condition along B? Anybody?
Y equals negative x,
Close.
negative
Extremely.
2x.
Nope.
Oh,
You had the
okay.
negative x right.
Oh, okay.
It's got a y-intercept of 4 though. So if we make that substitution in there, I don't like this pen.
So for-
It's too chunky. It's just too chunky.
Oh,
Made an equation out of that one variable.
So that's our new function, h of x. So h prime is negative 2x plus 2. So at x equals 1, if I set that equal to 0. So at x equals 1, y equals 3. So we'll need to check 1, 3. And I got the 3 plugging in the 1 here. Negative 1 plus 4 equals 3. In case you're wondering. Now we take a look at C. Along C, x equals 0. Which makes the whole function 0. So I wonder why 0.2 showed. Did I do something wrong here? Because otherwise, why is 0.2 the only thing showing up? I'm making an assumption with that 0.2, aren't I? Where else does y equal 2 in this picture? No, because then the fy doesn't equal 0 over there. That's interesting.
Were you expecting more critical points?
So, well, like if we do the derivative here, it's 0.
Yeah.
Which would imply the entire line on C is a critical point. Because what y was didn't matter. And yet when we did earlier, we found a critical point at 0, 2.
But not the rest of the line.
How is 0, 2 the only critical point there when the entire line is? That's kind of interesting.
So like graphically, like what would that look like if that's the case? Or what would that mean?
Well, if we're doing it as a function of height, z equals f of x, y, the entire function is 0 along that line. So when x equals 0, it doesn't matter what y is. X equals 0 along this line, the height is 0. So the height is 0. And then it's as we go away, as we go up, go these directions, what happens? This looks like it goes down. Like if I plug in like 1, 0, I got -2. So it's going downward as we go to towards x. And if we held x constant, if we held x constant, like any positive value, f is negative, or thus z is negative before y equals 2. Z would be negative down here and positive when y is greater than 2 for any positive x. So this is actually doing some weird wonky. This is negative down here. This would be positive up here. And it's making some plane like that. The surface, not plane.
In the end, it's the top-down view that's giving you
The
a triangle.
triangle, yeah.
But looking at it this way makes me think this anywhere the 0, 2 is just going to be like a saddle point. Let's take a look at doing what we do when we do the D's. So fx, f double x is 0. F double y is 0. Fxy is 1. And so is fyx.
It is a saddle point,
So D is just -1,
which is a saddle point.
which is a saddle point.
Which means all of these are saddle points.
So this entire line is like a saddle point. Saddle line, maybe?
Saddle.
Mr. Jones,
Yeah.
so for line B, or I guess like the hypotenuse of the triangle, how do you go about like creating a function that you then use to plug in? Like I don't know how to like figure out that line.
How to find -x + 4?
Yeah, well, just yeah.
Okay. Well, that's some algebra review for you. Y equals mx plus b. M equals y2 minus y1 over x2 minus x1. You found the slope. You recognize it was -1 because you said y equals -x. So when you have -1, you've got y equals -x plus b. Pick one of the points on the line and plug it in. And you'll find out what b is. So along that line, like Q2 is a point, well, it's easier probably just to use like 0,4. So 4 equals -0 plus b. So b equals 4. So y equals -x plus 4. I know it's been a while since you had to do some basic algebra, but we still got that in our tool chest.
So all we need to do then is just find the equation of the line, of that line.
Yeah, yeah.
Okay. Sorry, this whole time. I was a little confused.
So if they don't give you the equation of the line, you need to find the equation of the line. And hopefully the region they use, the line is something that you can figure out. Like in this case, it's just a line, not some weird polynomial. All right, let's put one more up. I want to talk about doing the boundary conditions on it. It's similar to your guys' homework. In fact, Eric was just asking about this a little bit ago. Let's just look since we only got a few minutes left, let's just look at the boundary conditions on this one. Or the boundary. So we've got a function and we're doing the unit circle that's in the first quadrant. R equals 1. So we would have 3 lines to check. X equals 0, y equals 0. X equals 0 would be here, y equals 0 is there. C is along the line x squared plus y squared equals 1. So there's a couple ways of going about doing it. One of them is treating this as solving for y or x independently. Y squared equals 1 minus x squared, or x squared. Since I have an x up here in the function, I'm going to write it as x equals plus or minus square root of 1 minus y squared. And then we could plug these each in individually up here. So as a function of only y, this would be plus or minus 1 minus y squared times y squared. And as a function of only x, we plug that in, we have x times 1 minus x squared. And then you could do h prime of x and g prime of y to find the partials there. Not equals, but next step, set those equal to 0. That's one option you have for checking those to see if there's any zeros along those lines. Another option you have is recognizing this is a unit circle. So along C, you can do it along the whole thing, but seems like more work for every other point. Along C, switch to x equals cosine theta, y equals sine theta. And now f of x, y is now just some function of theta. cosine theta, sine squared theta. And you can find the derivative there. And I'm going to work through that because I know some of you will fuck this up just because it's easy to fuck up. And I'm not talking about the derivatives. If we take the derivative, we've got a product rule with like effectively a chain rule inside. So if I do the derivative of the first, this goes to negative sine theta. I've got negative sine cubed theta. And then if I do the derivative of the second, I've got cosine theta and then 2 sine theta cosine theta. Because remember, this is sine theta squared. So it's a chain rule. So we have negative sine cubed theta plus 2 sine theta cosine squared theta. We want to set that equal to 0. The part where people might fuck up is yeah, we got sine thetas in each of them, but we can't divide by sine theta. We can't clear out a sine theta because it equals 0 in some places. So to address that, just factor out a sine theta. If we do that, I'm going to do the positive part first. I've got 2 cosine squared left. And I've got minus sine squared left over here.
No, you can't use identity.
Yeah,
Yeah,
as cosine squared.
yeah, they both have.
It's just cosine.
Yeah.
Well, not talking about that one. I was talking about-
So sine theta equals 0, or we've got 2 cosine squared theta equals sine squared theta. Tangent squared theta equals 1/2. Or you could try something different. Sine squared equals 1 minus cosine squared. So I could make this also 3 cosine squared theta. Let's see. I add that over and then I divide by the equals 1. So cosine squared theta equals 1/3.
Mr. Jones,
Yeah.
when you did 2 cosine squared theta equals sine squared theta, but you divided by cosine squared theta, how come it turns into 1/2 on the other side and not 2?
Because I fucked up.
Oh, that's good.
That's an excellent question. That's because Mr. Jones fucked up. That's probably easier to work with.
Yeah.
Let's go with that. Fuck all that. Because that means tangent theta is plus or minus √2.
Oh.
All right, 9 o'clock. I don't want to hold you guys back from other classes. The point is, when you're doing stuff, you don't always have to stick with X and Y. You might like using X and Y. Like these aren't too bad. Like G of Y sucks up here. But H isn't too bad.
Just a friendly reminder, please pull out the form I sent for my new time for SI at the end of the
And if
week.
you're coming to Starbucks, message me or Discord me. Let me know. Saturday and Sunday morning.
I'll be holding my regular SI hours tomorrow as usual.
Yeah, Mr. Jones.
See you guys.
Mr.
and
Jones?
Gals.
Mr. Jones?
Yeah.
Just real quick, can you pull up the absolute question with the triangle region? I want to take a picture of that real quick.
Yeah.
I can just copy some here. About this or put it on my laptop instead of.
See you later.
So there's the start. See ya.
Yeah, scroll down a little bit, up until like the B. Perfect.
I was just doing both parts since I didn't know which part you need a picture of.
Yeah, there you go. All right. Anyway, so I appreciate it. Thank you.
See you guys later.
And how,
Mr. Jones,
Yeah, Laura.
I just wanted to let you know you didn't post the lecture video for yesterday,
what are you doing, SI?
and if you
What
could
is it?
post it, please.
8:30 to 9:30 tomorrow and 12 to 6.
Did?
8:30 to 9:30 tomorrow and 12 to 6. And 12 to 2 tomorrow? Yeah. Okay, I get it. Yeah, okay. All right, and that one in
All
person.
right,
is-
it's posted, Laura. Thank you.
Oh.
All right, thank you.
Both?
Bye, have a nice day.
You too.
In person, what class?
Uh,
Is that the
I will
second?
put it in the announcements,